Hello everyone. Today we're looking at inequalities of triangles. Now, previously we've talked about how if we have two sides of a triangle that are congruent, or if a triangle is isosceles, then the angles opposite those sides will be congruent. But there also exist relationships between the sides themselves and their corresponding angles. Specifically, the idea of opposites. So in triangle ABC, the longest side and the largest angle are opposite each other. By that same token, in triangle ABC, the shortest side and the smallest angle are also opposite to each other. The side angle relationships of these obtuse scaling triangles are going to be true for all triangles and are stated in the theorem below, known as the angle-side relationships in triangles theorem. In a triangle, any triangle, the longest side is going to be opposite the largest angle, while the shortest side will be opposite the smallest angle. Now remember folks, order matters. The sides that form the angle cannot be the sides that are opposite the angle. So let's take a look at some practice problems. Here in number 1, we need to list the sides and angles of triangle PQR in order from smallest to largest. And it's nice, it already tells us the sizes for our sides. So we know that the smallest side is PR, segment PR, followed by segment PQ, followed by segment QR as the largest side. But we don't immediately know the measurements of the angles. But here's the thing, we don't care, because we can simply look at the sides and their opposite angles to identify which angle is going to be the smallest, because the smallest angle will be opposite the shortest side. The shortest side is PR, which means that the shortest angle is going to be angle Q. The medium angle is going to be opposite PQ. That's going to be angle R. And the biggest angle is going to be opposite our QR or P. Notice, folks, that we have an angle, and then opposite to it are the other two points of the triangle. This is always going to be the case. Number 2, we have to do the same sort of thing, but this time in triangle WXY, using the angles first. And we know that this, by now, should be a 90, a 51, then X. The X is missing, but some quick subtraction of 180 minus 90 minus 51 will tell us that X is going to be equal to 39. So our angles from smallest to largest are going to be angle X, angle W, and angle Y. To find the sides that are going to be in order from smallest to largest, we're going to look opposite the corresponding angles. So the side opposite angle X, well, that's going to be segment WY. The side that is opposite angle W, well, that's going to be segment XY. And the side that is opposite angle Y, well, that's going to be our segment XW. Organized from smallest to largest, we don't need to know the specific values so long as we know the relationships between them. All right. Now, in addition to our side angle theorems and relationships, there's also the triangle inequality theorem, which states that the sum of the lengths of any two sides of any triangle must be greater than the third side. So for instance, in triangle PQR, it must be true that PQ plus QR must be greater than PR. And that PR plus PQ must be greater than QR, and that QR plus PR must be greater than PQ. If these three inequalities are true, then we functionally have a triangle. If any of these inequalities are not true, we don't have a triangle. We can therefore use this triangle inequality theorem to identify which sets of three sides could make up triangles and which sets of three sides could not make up triangles. So let's take a look at some practice problems for this. Given each of these triplets, we want to identify whether or not we're going to have a triangle or not have a triangle. So 8, 15, 17. Set up our inequalities. 8 plus 15 greater than 17. That's a true statement. 8 plus 17 greater than 15. That's also a true statement. 15 plus 17 greater than 8. That's a true statement as well. Because all three of these statements have been true, this is going to be, yes, we have a triangle. In number 2, we have 6, 14, and 8. We set up our inequalities. Well, 6 plus 14 greater than 8, that's true. 14 plus 8 greater than 6, that's also true. But 6 plus 8 greater than 14, that's not true. And that's not true because 6 plus 8 is 14. 14 is not greater than 14. Therefore, we have no triangle for this. Number 3, 11, 2, and 8. Set up our inequalities. 11 plus 2 greater than 8. Yep. 11 plus 8 greater than 2. Yep. 2 plus 8 greater than 11. No, that's not actually going to be the case because 2 plus 8 is 10. 10 is not greater than 11. Therefore, this is going to be no triangle. Now, that's what we do when we have all three sides are known. Sometimes we won't have all three sides are known. When we have that situation occur, we need to use inequalities and compound inequalities to solve our problems. So, in this guided example, if the measures of two sides of a triangle are 3 feet and 7 feet, what is the range of the third side? The first thing we should always do in these problems, like just about any other geometry problem, is draw a sketch. And that's an ugly triangle. Let's fix that. Triangle. It doesn't have to be to scale, but let's put in what we know. Side of 3, side of 7, our unknown side, x. We then set up our inequalities for each of the pairs. X plus 7 is greater than, 3 plus 7 is greater than x. 3 plus x is greater than 7. X plus 7 is greater than 3. We now solve for our x's, isolate our x's. So 10 is greater than x. X plus 3 is greater than 7. We need to subtract 3 from both sides. X is greater than 4. X plus 7 is greater than 3. We have to subtract 7 from both sides. X must be greater than minus 4. Now the third one we found, x must be greater than minus 4. It's great that we found it, but we don't actually need it. The reason why we don't need it is because by definition of a side, we cannot have a side that is negative and we cannot have a side that is 0. So as long as these two are justified, are validated, we'll have a proper triangle. So now we're going to take these two inequalities and we're going to combine them to make a compound inequality. X values must be less than 10, but greater than 4. Another way to think about this, all x's that are between 4 and 10 are valid solutions to this problem. Let's do one more, and we'll call it a day. Same sort of situation, except now we have our sides of 13 and 9. First things first, make our triangle. 9, 13. X for our unknown value. Set up our inequalities. 13 plus 9 is greater than x. 13 plus x is greater than 9. And x plus 9 is greater than 13. Solve our inequalities. Well, 22 must be greater than x. X must be greater than negative 4. And x must be greater than 4. Once more, it's nice that we found a x must be greater than a negative number, but we don't exactly need that. Of the ones that remain, we set up our answer. X must be greater than 4, but less than 22. And that, folks, is triangle inequality. As always, if you have questions, please send me an email or ask during the class chats. Take care.